Let me tell you something that most people completely missed in the last 18 months. They saw headlines about chip restrictions, export controls, and technology decoupling, and they assumed this was just another chapter in the same old trade war story. Tariffs, counter-tariffs, negotiations, eventual compromise, the usual rhythm of great power competition. And on the surface, that logic makes total sense. Why wouldn't it follow the pattern? But here's where it gets interesting, and honestly, this idea flipped my entire understanding of how the global technology system actually works. What's happening right now is not a trade dispute that can be resolved through negotiation. What's happening is the deliberate construction of two entirely separate technological ecosystems that cannot communicate with each other. And the truly fascinating part, the part that should make every strategic analyst pause, is that the East isn't trying to catch up to Western technology anymore. They're building a parallel system that doesn't need the West at all. Think about what that actually means. For the past 40 years, the entire global economy has operated on a single assumption. Technology flows freely across borders, standards are universal, and innovation happens through international collaboration. Silicon Valley designs the chips, Taiwan manufactures them, China assembles the products, Europe writes the regulations, and the whole system hums along because everyone needs everyone else. That's not just an economic arrangement. That's the structural foundation of globalization itself. And that foundation is fracturing right now, not slowly over decades, but rapidly over months. The moment you understand that what we're witnessing is not a temporary disruption, but a permanent bifurcation, everything else starts to make sense. The chip export controls, the alternative payment systems, the separate internet protocols, the parallel satellite networks. These aren't isolated policy decisions. They're components of a deliberate architecture being assembled with remarkable speed and sophistication. To understand why this matters so much, you have to think about what technological interdependence actually represented in the global system. This is where the framework becomes essential. And I want to walk you through it carefully because once you see it, you can't unsee it. The framework is simple but powerful. Technological ecosystems function like biological ecosystems. They're not just collections of individual components, they're self-reinforcing networks where each element depends on and enables the others. In a healthy ecosystem, diversity creates resilience. But when you split an ecosystem in half, both halves face a survival test. Can each side replicate the functions the other side provided? And here's the critical insight that most analysts miss. The side that successfully creates a self-sustaining ecosystem first gains permanent structural advantage, because reunification becomes impossible once the systems mature in isolation. Let me show you how this played out historically, because the pattern is not new. Come forward to 1949, when the original Iron Curtain descended across Europe. The West and the Soviet bloc each built separate technological systems, different railroad gauges, incompatible electrical grids, distinct telecommunications protocols, parallel industrial standards. This wasn't accidental. It was strategic architecture designed to make the two systems fundamentally incompatible. And here's what happened. For 40 years, each side developed technology in isolation. Soviet scientists made genuine breakthroughs in metallurgy, mathematics, and aerospace. Western engineers dominated semiconductors, computing, and telecommunications. But the two streams of innovation couldn't merge. A Soviet factory couldn't use Western machine tools without rebuilding its entire infrastructure. A Western telecommunications network couldn't integrate Soviet switching equipment without total replacement. The economic consequence was predictable. The system with greater internal diversity, more robust feedback loops, and stronger innovation incentives pulled ahead. The Soviet technological ecosystem stagnated because it couldn't generate the variety of solutions that competitive markets produce. But here's the part that matters for today. The gap didn't become apparent for 20 years. Throughout the 1950s and 1960s, Soviet technology appeared competitive, sometimes superior. Sputnik, intercontinental missiles, nuclear submarines. The divergence became undeniable only when computing power started doubling every 18 months in the West, while Soviet systems remained essentially static. By 1989, the technological gap was so vast that integration was impossible. East German factories couldn't compete with West German productivity. Soviet telecommunications were a generation behind. The ecosystem had evolved so differently that reunification required total replacement of Eastern infrastructure. Now fast forward to today and ask yourself, which side is building the self-sustaining ecosystem faster? This is where it gets genuinely complicated, because the conventional wisdom has this exactly backward. The assumption in Washington and Brussels is that cutting off China from Western technology will cripple Chinese innovation and force capitulation. The belief is that China needs access to American chips, European machinery, and global research networks, more than the West needs Chinese manufacturing and rare earth minerals. That calculation made sense in 2015. It makes no sense in 2025. Here's why. China is now producing 60% of the world's semiconductors by volume. Not the cutting-edge 5-nanometer chips that get all the attention, but the 28-nanometer and larger chips that run cars, appliances, industrial equipment, and military systems. When the United States restricted exports of advanced chip-making equipment to China in October 2022, the immediate effect was exactly what Washington intended. Chinese foundries couldn't produce the most advanced processors. But here's what happened next, and this is where the framework reveals something most people missed. China didn't try to replicate the Western approach. They changed the game entirely. Instead of pursuing the same miniaturization race that drives Western chip design, Chinese engineers focused on chiplet architecture, where multiple less advanced chips work together to match the performance of a single advanced chip. Instead of relying on ASML lithography machines from the Netherlands, which the Dutch government now refuses to export, Chinese companies developed alternative fabrication techniques that trade some efficiency for complete supply chain independence. And instead of competing in consumer electronics, where cutting-edge chips matter most, they concentrated on industrial applications, electric vehicles, telecommunications infrastructure, and military systems where slightly older chip technology works perfectly well. The result is not Chinese technological inferiority. The result is technological divergence. Let me give you a concrete scenario that illustrates what this means. Imagine a European automotive manufacturer in 2027 trying to build electric vehicles. They need batteries, electric motors, power management systems, and advanced driver assistance features. Every single one of those components now exists in two incompatible versions. A Western version using American chips, Japanese sensors, and European software, and an Eastern version using Chinese chips, Chinese sensors, and Chinese software. The two systems use different charging standards, different communication protocols, and different safety certification frameworks. The manufacturer faces a choice. Build for the Western market using Western components, accepting higher costs and limited battery availability because China controls 80% of global lithium refining and 70% of battery production. Or build for the Eastern market using Chinese components, accepting exclusion from Western markets due to security concerns and regulatory barriers. What they cannot do is build one vehicle that works in both ecosystems, because the ecosystems are deliberately designed to be incompatible. That incompatibility is not a bug. It's the core feature of the system being constructed right now. Now add to this something that makes the divergence particularly significant. The financial architecture is fragmenting along the same lines as the technological architecture. China launched the Cross-Border Interbank Payment System, CIPS, in 2015 as an alternative to SWIFT, the Western-controlled payment network. For years it processed minimal volume, maybe 2% of cross-border transactions. But in 2023, after the West froze Russian foreign reserves and expelled Russian banks from SWIFT, CIPS volume increased 50% in a single year. Not because Chinese technology was superior, but because half the world suddenly realized that the Western financial system could be weaponized against them at any moment. The pattern repeats across every technological domain. GPS, the American satellite navigation system, has a Chinese alternative called Beidou that now has more satellites than GPS and covers the entire planet with better accuracy in Asia and Africa. The Western Internet backbone, controlled by American companies and subject to American surveillance, has a Chinese alternative being built through fiber optic cables across Central Asia, the Middle East, and Africa, with Chinese equipment, Chinese protocols, and Chinese control. The Western undersea cable network that carries 95% of intercontinental data has a parallel Eastern network being constructed with $500 billion in Chinese infrastructure investment. Each of these systems alone might seem like standard competition, but when you hold them all together in the same frame, what you see is not competition within a unified system. What you see is the construction of two separate systems that are designed from the ground up to exclude each other. And here's the truly significant part. The Eastern system is being built to serve 4.5 billion people across Asia, Africa, the Middle East, and Latin America, while the Western system serves perhaps 1.2 billion people in North America, Europe, Japan, South Korea, and Australia. Think about what happens when these two ecosystems reach maturity, probably sometime between 2027 and 2030. A A company in Vietnam wants to build a telecommunications network. They can choose Western equipment from Ericsson or Nokia, which costs more, comes with Western financing that requires economic reforms and political alignment, and integrates with the Western internet backbone. Or they can choose Chinese equipment from Huawei or ZTE, which costs 40% less, comes with Chinese financing that requires no political conditions, and integrates with the Eastern internet backbone. For Vietnam, which has complex relationships with both China and the United States, this is not just a purchasing decision. It's a civilizational choice. Which ecosystem do you join? Because once you choose, switching becomes extraordinarily expensive. Here's a specific data point that illustrates how quickly this is moving. In 2020, Huawei equipment was installed in telecommunications networks in 170 countries. After the United States designated Huawei a security threat and pressured allies to remove Huawei equipment from their 5G networks, you might expect Huawei's market share to collapse. It dropped in Western-aligned countries. In the developing world, it increased. Huawei now has 5G contracts in more than 100 countries, most of them in Asia, Africa, and the Middle East. Those contracts are not just about telecommunications. They're about which ecosystem those countries will operate within for the next 30 years. Because telecommunications infrastructure determines which apps work, which payment systems function, which entertainment platforms are accessible, and ultimately, which economy you're integrated with. The implications cascade in ways that most strategic analysis hasn't fully absorbed yet. Start with the immediate tactical consequences. Western technology companies that spent decades building global supply chains now face a world where those supply chains no longer function across the ecosystem boundary. Apple can't manufacture iPhones in China if Chinese factories can't access American chip designs and American software tools. But Apple also can't easily move production to India or Vietnam if those countries are integrating into the Eastern ecosystem and face compatibility problems with Western components. The assumption in Silicon Valley has been that China needs the Western market more than the West needs Chinese manufacturing. That assumption is being tested right now. China's domestic market is 1.4 billion people with rapidly rising incomes. Add the countries integrating into the Eastern ecosystem, and you're looking at a potential market of 4.5 billion people. That's not a market you can ignore if you're a technology company, but accessing it increasingly requires using Chinese components, Chinese platforms, and Chinese standards, which means building products that don't work in the Western market. Now extend this to the regional level, because the technology bifurcation intersects with existing geopolitical tensions in ways that compound both. South Korea, for example, is home to Samsung, one of the world's leading chip manufacturers, and SK Hynix, a major memory chip producer. These companies generate 60% of their revenue from China. When the United States pressures South Korea to join chip export controls against China, South Korea faces an impossible choice: align with the United States and lose access to the Chinese market, or maintain access to China and risk losing access to American technology and security guarantees. There's no middle path when ecosystems are incompatible. The same pressure is hitting Taiwan even harder. Taiwan Semiconductor Manufacturing Company, TSMC, produces 90% of the world's most advanced chips. Both the United States and China depend on TSMC for everything from smartphones to missile systems. As the ecosystems separate, TSMC cannot serve both. If TSMC aligns with the Western ecosystem, China must develop domestic alternatives regardless of cost. If TSMC maintains access to China, the United States must build domestic fabrication capacity regardless of expense. Either way, the integrated system that made TSMC profitable is breaking apart. The economic consequences go beyond individual companies or countries. The entire logic of comparative advantage, the theory that says each country should specialize in what it does best and trade for everything else, assumes a unified global market where goods and capital flow freely. When the market fragments into incompatible ecosystems, comparative advantage stops working. Instead of specialization driving efficiency, redundancy becomes necessary. Both ecosystems must develop every capability internally, even if doing so is wildly inefficient, because they can't rely on the other ecosystem for critical components. This is already happening. The United States is spending $52 billion to rebuild domestic semiconductor manufacturing through the CHIPS Act. Even though American labor costs make this economically irrational, compared to manufacturing in Taiwan or South Korea. China is investing an estimated $150 billion in semiconductor self-sufficiency, even though much of this investment duplicates existing capacity and produces chips that cost more than importing them would. The European Union is spending $47 billion on its own chip fabrication initiative. Japan, South Korea, and India each have multi-billion-dollar programs. All of this investment is economically wasteful if you assume a unified global market. It's strategically rational if you assume permanent ecosystem separation. Now push this to the global level, and what you see is not just economic inefficiency, but a transformation in how power operates in the international system. For 70 years, American power has rested on control of global technological standards, the dollar as reserve currency, and international institutions that encode Western preferences into global rules. All three of those foundations are eroding simultaneously. When 5 billion people operate in an Eastern technological ecosystem with alternative payment systems and parallel institutions, American leverage diminishes not because America becomes weaker in absolute terms, but because the system America dominated stops being universal. Think about what this means for sanctions, the primary tool of American foreign policy over the past 30 years. Sanctions work when the target country needs access to the Western financial system, Western technology, and Western markets. When alternative systems exist, sanctions become considerably less effective. Russia, after being hit with the most comprehensive sanctions regime ever imposed on a major economy in 2022, saw its GDP contract 2.1% in that year, then grow 3.6% in 2023. Not because sanctions failed to hurt Russia, but because Russia could pivot to the Eastern ecosystem for technology imports, use alternative payment systems for trade, and sell commodities to countries that hadn't joined the sanctions regime. Iran provides an even clearer example. Under sanctions for decades, Iran never capitulated because it could trade with China, use Chinese payment systems, buy Chinese technology, and export oil to countries using Eastern infrastructure. The assumption that economic pressure would force political concessions only works if there's no alternative economic system. Once an alternative exists, pressure disperses rather than concentrates. This brings us to the structural level, the deepest implications for the international order itself. The system that has governed global politics since 1991, sometimes called the unipolar moment or the liberal international order, rested on a simple structural reality. There was no alternative to integration with the Western-led global economy. Countries could choose their political systems, but if they wanted prosperity, they had to accept Western investment, Western technology, Western institutions, and ultimately Western influence. That structural reality is dissolving right now, not because the West is failing, but because an alternative system has matured to the point where it offers genuine choice. The historical parallel that comes to mind is the period between 1945 and 1949, when the post-war international order was still fluid. Countries could potentially align with either the American-led capitalist system or the Soviet-led communist system. Once that choice solidified around 1950, it became extraordinarily difficult to switch sides. East Germany couldn't become West Germany. South Korea couldn't become North Korea. The ecosystems were too different, the integration costs too high, the political commitments too deep. We're living through a similar moment of crystallization right now, where the choices countries make between 2024 and 2028 will determine their position for the next 50 years. So when you zoom all the way out and look at the complete picture, what you see is not a temporary trade dispute or a bargaining position that will eventually produce compromise. What you see is the deliberate construction of two incompatible technological civilizations, each building the infrastructure to sustain itself without the other. The West is betting that its technological advantages, particularly in cutting-edge semiconductors, artificial intelligence, and biotechnology, will prove decisive. The East is betting that control of manufacturing, rare earth minerals, battery technology, and a larger potential market will create a self-sustaining ecosystem that doesn't need Western innovation. The real question is not which side wins the direct competition, because direct competition isn't happening. The question is which ecosystem can assemble a complete, self-reinforcing technological stack first. Can China replicate advanced semiconductor manufacturing, develop world-class AI systems, and maintain technological parity in military systems without access to Western research? Can the West rebuild manufacturing capacity, secure reliable supplies of rare earth elements, and maintain innovation leadership without access to Chinese production scale and cost advantages? The honest answer is that both sides face genuine challenges, and both are moving faster than most observers expected. But here's what should keep strategic planners awake at night on both sides. Once these ecosystems fully separate, probably by 2030, the incentive for conflict increases dramatically. Right now, economic interdependence creates powerful constituencies for peace in both systems. Corporations with supply chains crossing the ecosystem boundary push against escalation. Financial institutions with investments on both sides advocate for stability. Those constituencies are disappearing. When Apple no longer manufactures in China, when Samsung no longer depends on the Chinese market, when Western banks no longer hold Chinese assets, the economic cost of confrontation drops, while the strategic value of preventing the other ecosystem from expanding increases. The pattern is structural, not accidental. Empires do not compete within the same system indefinitely. They either reach accommodation through spheres of influence, or they fight for dominance. The global technological system is splitting along those same lines, creating separate spheres that cannot peacefully coexist in contested spaces like Taiwan, the South China Sea, or the semiconductor supply chain. And the next time you hear about chip export controls, technology transfer restrictions, or infrastructure competition in the developing world, try holding all of these things together in the same frame, because they're not separate stories. They're different angles on the same story. The story of how the unified global system that defined the past 40 years is fracturing into something that looks increasingly like the Cold War world our grandparents knew, but running on fiber optic cables instead of railroad tracks, and moving at digital speed instead of industrial pace. The conditions for that fracture aren't assembling, they're already assembled, and the window for reversing course, if it ever existed, has probably already closed.